Welcome to Algebra 2. This is our second section of quadratic functions, and today we are going to be solving the quadratic functions by graphing. So, to solve a quadratic equation, you would have to set it equal to 0. So we would have 0 equaling our ax squared plus bx plus c. So this, we know what happened when our y value is 0, and that tells us where we cross the x-axis, which would then allow us to actually solve this. So all we need to do is we need to graph our quadratic and then figure out the numbers in which it crosses the x-axis at. So here, I want to graph the quadratic x squared minus 3x minus 4. First off, we know that it crosses the y-axis, the y-intercept is -4, and we know that because that's our last value here. If we plug our x's in for 0, we would get -4. And then we can find where our axis of symmetry is by figuring out what -b over 2a is. So in this case, our -b would be a positive 3 over 2 times a, so 2. Well, so our axis of symmetry would be at 3/2. So here, if I'm making an xy chart, I'm going to want to put down 3/2 or 1.5 for sure for a point. So that would be 3/2 squared minus 3 times 3/2 minus 4. And we'll figure out what that is. So 3/2 squared is 2.25 minus 3 times 3/2 would be 4.5, or 4.5 minus 4. So 3/2 squared minus 3 times 3/2 minus 4 is equal to -6 1/4, or -6.25. So here at 1.5, we are at -6.25, and that is also our axis of symmetry here. So notice we have this point here at -4, 0. So we have that same point on, or at 0, -4. So we have the same point on the other side of the line because it is symmetrical. So now we're going to plug in a few more points to figure out what else we would have. So here we know what 0 is. So let's maybe plug in -1 for your x. So here we have -1 squared minus 3 times -1 minus 4. -1 squared is +1. The -3 times -1 is a +3 minus 4. 1 plus 3 is 4, minus 4 is 0. So that's at the point -1, 0, which is right here. Now because we are symmetrical, we can go the same distance away on the other side, and we would also have this point. So that gives us enough information to graph that parabola, the quadratic. It looks like that. And then to solve this, we just need to look and see where it crosses the x-axis, which happens right here and right here. In our xy chart that we made, we were looking to see that our y was 0, and then we knew we crossed the x-axis. So those two values are when x is equal to -1 and when x is equal to 1, 2, 3, 4. So those are our two solutions for x here of -1 and +4. All right, so we'll do one more example of this. This time we want to solve x squared minus 6x plus 4 equals 0. So once again, we'll start off by graphing it. So we know immediately that the y-intercept here is 4, because that's our ending number. So we can put the y-intercept on there at 4. And then we want to figure out what our axis of symmetry is. So -b over 2a. So -b in this case would be a +6. 2 times 1 is 2, so this is 3. So when we do our xy chart, we definitely are plugging in 3 for our x. So that would be 3 squared minus 6 times 3 plus 4. 3 squared is 9, minus 6 times 3 is 18, plus 4. Well, 9 minus 18 is -9, and then if we add 4 on, we have -5. So we have the point 1, 2, 3, -5. 1, 2, 3, 4, 5. This is our vertex and our axis of symmetry. So this also tells us, since we know that we had the y-intercept of 4 on the left-hand side, since it's symmetrical, we can put that same point by symmetry on the other side. Now we do have a few more points that we need to try to see if we can figure out where we actually do cross the x-axis. So this happened at positive 3, so we're going to plug in 2 for our x, and we will also plug in 1 if we don't get what we need from 2. So when x is 2, we have 2 squared minus 6 times 2 plus 4. 2 squared is 4, minus 6 times 2 is 12, and then plus 4. So if we take 4 minus 12, we get negative 8, plus 4 is negative 4. So we have the point 2, negative 4, so right here. And since we have this point symmetrical across the other side, we also have that point right there. All right, we still don't know exactly where we're crossing that x-axis, so we will also plug our x value in for 1. So if we plug 1 in, we'll have 1 squared minus 6 times 1 plus 4. 1 squared is 1. 6 times 1 is 6, so minus 6 plus 4. 1 minus 6 is negative 5, plus 4 is negative 1. So this is the point 1, negative 1, which is right here. And then symmetrical to the other side, so we also have this point. Now notice, we are just going to have to draw our parabola in as is, because now we have all the consecutive x points. We have a point when x is 0, when x is 1, when x is 2, when x is 3, and we did not get an exact value, an exact x location for where we cross. Instead, take a look that we are crossing kind of in between some numbers. So when this happens, when we don't cross exactly at an integer, so there are no zeros over here, what we're going to do is we're going to say which two values are in between. So here, our x is in between. Well, here, this is in between 0 and 1. And it's also in between 0, 1, 2, 3, 4, 5, and 6. It's also in between 5 and 6. So our zeros, we can also call them our solutions. We can also call them our roots. Any of those, they fall in between 0 and 1 and 5 and 6. So sometimes this will be your answer because we don't have exact solutions.